Okay, so now we're gonna build for logistic regression. In fact, this is one of my favorite model because it's quite simple and can give sometimes very good results. Now in logistic regression, this time what I'm gonna do, I'm gonna do some oversampling. Why I'm going to do oversampling means what is happening here that we have noticed earlier that we had a lot of data in class 2, class 4, class 6 and so on, but there were few classes like class 8 and class 9 where we had very less data. Now, due to this also we can have some impact. Now, in order to resolve those impact, what we will do, we will try to balance the class. So there is a parameter which you have to just pass and it will help you to oversample. It will automatically just do a oversampling within the data and will balance all the class for you. So this is what basically do. Now, if you look at this, so I'm going to create this logistic regression with both, one with balancing and one without balancing, so that you get an idea that what is going to be the difference between them if we balance the data set for all the classes and when we don't balance it, right? So that will be very interesting. So again, the same thing. Now I'm going to use one hot encoder. So again, the same thing. If you look at it's LR technique with balancing. But one thing about LR is that you can work on the high dimensional data. So that's the reason we will go back to one hot encoding. Okay. So you can work with basically with this very well. It have no issue with respect to this. So now let's go back and see. So when we are balancing the class, you can notice here that we are getting basically this sort of log loss, and we have to look at the minimal. So it's very difficult to see it from here. So let's do it from here. So the minimal, the value we got is 0.001, right? So let's see to this. So even if you look at it, you can see that it's 0.001, and this is the place where my log loss is 1.10, and remaining log loss you can see it's pretty high. Now if we draw a plot also, it's telling me the same thing, 0.001 we got the minimal log loss, and here we are just basically looking at a training test and this loss. So I'm not going into all these basically line by line of code, because again we are seeing this again and again lot of time, and you can see that we are again and again following exactly the same thing, SGD classifier, calibrated classifier. So we're not putting any such different things in this case. So we got the values here, and we got 0.61 as my train loss. So let's put it up here. 0.61 is the train loss. For my cross validation, I got 1.1. So let's put 1.1. And for my test loss, we got 1.06. So I got 1.06. And let's look at the misclassified point here. So if I come back and look at this, we got 35.33 as misclassified point, 35.33 as misclassified point. Now, by now you can see that though my log loss is lesser here, right? If you compare this, definitely log loss is less, but definitely misclassified points are little more in this case, right? So misclassified are coming higher in this case. Here we have 33.83, here we have 35.33, right? So they are almost matching up, but let's go ahead and see a few more things before we can conclude anything up. So I don't want to do any conclusion here that my LR is working better than KNN also. But if my metric is going to be log loss, then definitely my LR is doing better, right? If that is going to be my metric, because that's what we want to basically hold in this case. So let's go back and again look at few more things. Like we have got this data sets. Now we got our log loss, and one thing which I want to show you up, that how you are putting into the code that it's basically going to be balanced. So you can see that when you put your SGD classifier here, we are basically putting the balanced here. Okay, class weight as balanced. Just you have to pass this parameter and it makes your class balanced. So it takes care of all the overfitting and all that for you. Second thing is, you can see that the loss I have put it as log. So basically when you say loss as log, it means that we are talking about logistic, because that's a logistic loss. So logistic loss, basically when you put, it's a logistic regression. But if I would have just changed this loss to hinge, then it would have become an SVM classifier. So that's the only difference between them. And you can see that in calibrated classifier, I'm always using almost sigmoid and it's all working, right? So that's a small change which I also want you to kind of focus on. So once we got that, let's look at the confusion matrix. So my confusion matrix came out to be again in the same way. So you can see that we can see that we do have a good high values coming up basically on this part, and we do still have some concerns with respect to 7 and 2, but that's okay. There will be definitely some points, but definitely is doing far better. So again, this interpretations, now we have learned a lot, so we don't need to bother much about it. So almost every time we are getting same. Now here, one more good thing about logistic regression is that it's very good in terms of interpretability. So when we talk about interpretability, it's kind of awesome. So in that cases, it's because it looks at the weights and all that, and based on those weights and coefficients, it basically gives you the interpretability. So this is a very simple function for achieving the same. And when we have done this, you can see that we are going to import this and again look at the interpretability. So even you can see that by my predicted class 7, we have gone through this multiple times. So you can see that for the 7th probability, we are getting 87.62, which is awesome, right? That's the reason my prediction is coming out to be 7. And these are the reason, like you can see that we do have 35th feature which is activated present in the test point. So this is basically the interpretability part. Even we can also look at an incorrect data where we do have predicted class to be 6, but the actual class was supposed to be 4. And you can see that here, definitely if I look at it, 1 2 3 4 5 6, we got 48.27%, and that's where it got confused. But one very interesting thing, if you note here, that it's all, this is the place where this gets interesting. You can see that though my interpretability came out to be bad, because here since my sixth class was having 48.27 probability, that's the reason my basically it returned you that okay, it's a class 6. But at the same time, can you notice this part? Class 4 was also having 42.29, right? So definitely by looking at the probability itself, we could have said that yeah, there is a good confusion happening between these two classes because they are very close. So that's where it got, but it's not always going to be the case. Okay, so keep that in mind. It's not always going to be the same case where you are going to notice that it's gonna give you close probabilities. There is a chance that maybe one of the probability which you have predicted wrongly may be very high, but still it is going to give you wrong results, because again, machine learning is not a god. It can bring you closer, but you cannot say that it's going to give you the perfect results. Now let's come back and see a few more things. Now we have just seen it with respect to class balancing stuff, but what about if my classes are not balanced? I don't want to go with that parameter class balance set. I don't want to do oversampling here. So in that case, if we go ahead and look at it, we do getting basically some sort of this again the same part, and we can see that it's going to be minimal for 0.001. So let's go and check that. So we are going to get 0.001. Yes, we have 1.09 for this, which is quite less. And then we have computed again our train loss and this. And if you look at this, we are nowhere using the balancing part here. So the balancing is not true in this case. So in this case, we are getting the train loss as 0.61. So let's note down. So it's going to be 0.61, which is same. And this is for LR without balancing. Okay, and again we are going with one hot encoder itself. So this is what we have got. Now let's look at the cross validation. My cross validation comes out to be 1.86. 1.86. Can you see a red flag? I hope you can. And we do have I'm really sorry, I have written down the wrong term. It's 1.09. okay, that's why I was thinking that it's a red flag. So it is going to be 1.09, and if we go back, it's going to be 1.07. So we got 1.07, and let's look at the misclassified points also as well. So if we go back and look at this, my misclassified is 34.77. 34.77. Definitely it's working better if I look and compare with respect to my width balancing. Okay, this is interesting results of machine learning, right? Sometimes it do happens that you can, when you thought that balancing will help, but it didn't much, right? Though the misclassified point have kind of reduced, At the same time, basically here if you look at your log loss is almost coming similar, right? So you can see that for KNN and both the LR, my log loss are very similar. There's not much difference here. So maybe we can go again with respect to whatever we want to. So, but this is giving me a good result. Means I cannot say that LR is working bad here. But definitely we would like to see other classifiers also, to see that if they can somehow perform better than them. So we have to still wait for that particular moment. So now let's go back and let's look at few more things here for this. Again, you can look at the confusion matrix. For confusion matrix, still we have some confusions happening, but there are few classes which are getting now very nicely classified with the value 1. Even for class 9 we are getting the value 1. And you can also see that these values are also higher, which is good. There are still confusion happening in 3 and 9 now, and 2 and 8. Okay, so there are still confusion, but you cannot skip that. At the same time, now let's look at the testing some points. So if you look at the testing, my predicted is 7 and my actual is 7. So let's go and see whether it's what's the value. Yes, and yes, you can see that this is the lower value. So that's the reason we are sorry, this is a higher value of probability. That's the reason we are getting this value. So it's almost going to be 86% probability, and we got the perfect output in this case, right? So, and this is the interpretations. We have already talked about interpretations a lot, so we need not repeat it again and again. So we got basically this result with respect to my LR results. Now, further to this, we are going to look at SVM models. We will see that how linear SVM is going to work in this case.